Alright, last time we finished off our map types, so we did a bunch of like refactors, right? We changed the type so that they're nice interfaces now. I'll actually go to the types file. They're really nice interfaces. Basic struct field, array struct field, map struct field, which is pretty cool. And this leaves one thing to do. One major bit of work to do. There's a couple of others, but there is one major thing to do. That thing is anonymous structs. And I'm not super sure how I will tackle anonymous structs, to be honest. Not super sure. So let's write a test for it and figure it out. So test basic parse anon struct testing T. Alright, so let's just grab the boilerplate. A that has hello, that is struct that has world string. If I'm not mistaken, that's right. I don't actually need to take it all the way down there. I could just do it here. Yes, that's correct. And you know, I have an idea of what the output would be. It would be an object with string, world string. Perfect. Don't need this one. Don't need this to be an object with hello object of world string. And I think I put a comma here as well. Yeah, I do. Cool. So that's what it would be. Great. So let's run that. Go test dash run test basic parse anon. We currently don't support ast.struct types. Great. So how would we even represent these in code? I'm not sure. Okay. Yeah, it would go down to here. So the case would be a star ast.struct type. T dot. Okay, let's just have a look at the interface. So we have a position of struct of the keyword struct, and we have a field list of field declarations, and field list as a list. Okay. Incomplete. True if source fields are missing. Huh. True if source fields are missing in the fields list. What does that mean? Golang incomplete struct. What is this? I don't know. Let's ignore it until we find out. And then field lists we are actually quite familiar with because we work with them. So I think this might be all right. We're doing integration tests, we're not actually doing unit tests on the front end part, so this will be slightly more difficult to test. That's fine. Yeah, we're testing. Oh, yeah. Yeah, eventually we would have to separate out those tests, but that is not now. T dot fields dot list. These could very much go in like an ordered struct. And the order is uint. And we could start by setting it to like 9999. Actually, the order doesn't really matter because they're not going to get referenced. But we're going to have to add another type here, I'm pretty sure. Type anon struct field struct. And this really is just going to have like fields, which is an array of struct field, and that's it. And let's just give it a name, like we do to the others, and I'll struct field. Okay, so we could do we actually need to recurse on this array struct field, array struct field. Yeah, we need to go down into here, which is the ordered struct type that contains the st struct, its order, from file and file, and those will be very much nil. Okay, well let's write something. Fields error is equal to p.parseStruct. Ordered struct type. Struct type is going to be t. That's it. And if error is not equal to nil, return struct fields array and the error. Otherwise, return the fields and nil. Or stop being silly. Oh, wait, no, we need to construct something here. We need to actually go return struct field and this struct field. Do at any point do we return? I don't think at any point we return more than one, so this doesn't need to be a return array type, because actually that was split over here. The only reason we have an array type is because of the embedded structs. But I guess it does. Yeah, we'll remove that. This is going to be a non-struct field type with the name, field name, and then the fields is going to be for fields. And the switch should be exhaustive. I think this is enough. Now we need to do it here. Switch should be exhaustive, yeah. Oh, now this is weird. The reason this is weird is because we can now have many dependencies. Oh yeah, that okay. That's some rather annoying things. And it could just also be empty, right? We could be. Could I have type a struct hello struct empty? I can. So it could have no dependencies. Oh, that's something. But let's not think about the future, because because TDD will write tests to implement the future. Not implemented. Where is not implemented thrown? Here. Yeah. This could also be a switch, to be fair. And it probably should be a switch. Yeah, let's make it a switch. T on basic on field dot type case basic struct field delete inside case array struct field delete inside case map struct field delete the inside and then this is going to be T and then the default case, which is you. And now, yeah, this whole thing is a switch. Oh, can I do I need them? No, I don't need them. Okay, don't need scopes. Pretty cool. Pretty cool. Just to double check if I do a skip, I run everything. Okay, we should commit the refactor at least on the back end here. Refactor type checking. It's not type checking, it's type inference into switch. I don't think it's that really, but okay. We can go back to testing this. We could go so fast I could actually like run the entire test suite, like, and it just works. It's so good. Okay, so I mean, I'm pretty sure the front end is fine. Oh yeah, one other thing I was gonna do is I was gonna get rid of you and just return this. This is actually like quite nice. Invalid composites, structures. Oh, because I'd have to return. Yeah, that's fine. There we go. Past dependency. As far as I'm aware, you don't actually need this. Do basic struct field. Okay. So I don't need this check anymore. I can do value type pass map field. Also doesn't need to be an array. Like we could just actually just return no. That's it. Yes, that is it. And then yeah, now we have just a little bit of more complexity here because we need to check the field or the error. If error is not equal to nil, then we return struct fields and the error. Otherwise, we need to return an array of struct field composite by the error and nil. Struct fields. There we go. Let's just... Good, it all works except that one. The one we did. Refactor return types to be mostly singular fields. Great. That's nice. Just something I noticed, and it took what, 5 minutes? 10 minutes maybe. Now we can focus on this. So it's not implemented on the back end here. Let's implement it. Case anon struct field. Yeah, this should be pretty okay. Because we have t and t dot. What do we have? Yeah, I mean, this is gonna just be like super recursive almost, like we're gonna do an array and get single field. Output is equal to this for underscore value of range t dot fields. Something is gonna go wrong with the counter, I think, but maybe not. We're gonna do... Oh, actually the output for now is going to be output. It's going to be opened, and then the output at the end is going to be closed comma, and then return output nil. And we're going to do output plus or equal to get single field validators counter v struct field. Field output error. If error is not equal to nil, return on the error. Otherwise, output is equal to field output. Not just field output, but plus or equal to. This is where it actually needs to be a little bit smarter. I mean, yeah, if I extract this here, then I can use it. Kind of, because it has that, but this is not the nicest interface for some of these. This is becoming nice, but it's not that nice yet. And I'm also gonna mess up indenting here, so so it does everything, and I think I need a comma and then a new line, and that should mostly be it. And yeah, kind of, it messes up indenting, like I thought. Oh no, output object. Okay, let's figure out where our extra commas and such are coming from. From get single field. Yeah, so do I not need this? Might not, I don't think I do. Yeah, I'm getting that extra comma. Yeah, what if I get rid of you? Yeah, you're mostly good. But the indenting is off. Which, you know, it's fine. Oh, I don't really want to mess up some, like the indenting logic into here, but I'm going to. Indent event. So you just go to 0. Oh no, you indent +1. Always just add 1. Get single field. Indent event. Indent. And then indent +1. You start at 0. And let's just write func get spaces indent uint string output +, space this for 0 I smaller than indent I plus alpha plus or equal a singular space, 2 spaces even. There you are. Okay, just var I uint 0. There we go. Turn output. Yeah, I don't really like what's going on here, but because we're messing up some logic. And the get single field gets spaces from the indent. It's just always do indent +1, I think, because otherwise we wouldn't have any. Oh dear. Backend, let's go tests. Okay. Okay, they all still pass. And, you know, nearly. Now the next thing is get spaces indent, the current indent. This one. Okay. Nice. Cool. That actually works. Feet. Working simple non-types. Okay, let's do more. Test basic parse non-struct 2. Let's put you as 1 and this is 2. World string a map string array of int, and then another struct. It's going to be a struct of b string, and then map, say b on the top level is going to be a map, an array of anonymous struct. Let's get rid of this here. With C is also string. Let's just double check that's correct. Nice, there you go. Hello. World, and then it's gonna have a. It's gonna be a record. So record of object b string. Oh what? And then it's gonna have another struct, which is gonna be an object of a is a record. Oh, I actually got that the wrong way around. A is a record of an array number, and apart from another struct, we're gonna have b, which is an array of an object, c, which is string. Damn, that's something, isn't it? Okay, what is wrong? Well, I guess what's wrong is the indenting is just all over the place. Well, kind of. It's mostly okay. It's just messed up when you have an array of objects and it tries to go one too far because it thinks it's in. Yeah, it thinks it's one further than it is. I'm actually not sure how to solve that problem. Nor do I immediately want to, really. I can keep it like this. The good thing is that it did work. Or one further even. What else is wrong? So we got object, string, record, array, number. Const a, object, hello, object, world, that goes to string, a, which is a record of an array of number, comma, another struct, which is an object that contains b, and that's a string, b, which is an array of objects, oh, and then c has to be nested a little bit, and you go into there. That's it. So the indenting is a bit messed up, but more tests. But apart from that, it's okay. Is that it? I mean, this is pretty. No, that is not it. Because we haven't tackled dependencies. Nested dependencies. Okay. Let's do that. And I feel like that might actually be kind of annoying. So I'll end this on the shortest video yet so far on how we it's actually quite an interesting video, how we adjust everything a little bit to accommodate for these structs. I don't like the way the front end, the back end, which is what generates Validators, is structured. This function here is like the main structs the Validator function. I don't really like it, because it's not separated out. It means that I have to do this logic here, and I don't really want to. Like I have to do get single field, and I have to keep track of the indentation, and you know, it's just not the nicest. So yeah. Yeah, anyways, thank you so much for watching, and I'll catch you in the next one.